Hello, everybody. This is Paul Speciale. I'm the Chief Marketing Officer at Scality. It's time for another edition of our podcast, and I'm joined as usual by my colleague Giorgio, our CTO. Hi, Giorgio.
Hey, hi Paul, hi everybody.
Hello. Um, as usual, we try to pick relevant and timely topics. Today, we want to talk a little bit about storage in the context of AI. So I think everybody understands that AI has all of the usual infrastructure elements. Compute is obviously a very big part of it, GPUs, but so is storage. And we really want to start thinking about this afresh. There's been this kind of image over the last few years that AI really has a dependency on storage classes, kind of tiering model. We want to look at those assumptions and kind of think about how this goes in the future. One of the senses we have is that the silos or the tiers are starting to blur a lot, and that there's really a different assumption to be made in terms of the heat of the data, the temperature of the data, whether it really is cold at any point or if it stays warm. So why don't we get into that? So Giorgio, if we can click forward one slide, I think the default view that people have of the storage pyramid for AI is as follows, right? There's a very, very hot tier kind of in RAM and DRAM, and now we have HBM in the GPUs. That's really where the sort of active activity happens, but then it's tiered behind that for greater capacities with very, very fast SSD, flash, something like TLC flash. You might have a different quality with QLC, but then it gets to hard drives. And of course, tape makes a lot of sense, especially if you think in this default assumption that cold data is cold and that there's a lot of data that stays cold. The problem with this model, Giorgio, as you can echo, is that it means you have a lot of I/O to migrate the data across the tiers. And I
Yeah.
think the other comment or the sort of assumption we've had is that apps are mostly stateless. So we'll have to get into that as well. But maybe talk about this data cools down over time assumption. I think that
Yeah,
is fun.
so this pyramid assumes that the data stays into its band, right? So cold
Mhm.
data will stay cold and warm data will stay warm. But what we see is that is hard to predict, right? And at the end of the day, if there's too many movements between classes but are different systems, so different metadata, different data formats sometimes, then you generate more load because of the migration and tiering than the actual application need, right?
Right.
Like if you send to tape, but you have to group things into containers, and then you have to refresh and reload that data into DRAM. If the container don't have data that's related to each other, you end up trashing the tape drives, right?
Right. Right. Makes sense.
And that's not what you want. And so we think that things are evolving, and this is a picture that's too perfect.
Yeah, agreed. And you end up basically burning a lot of your expensive cycles on just moving the data around rather than
Yeah.
doing the important work. So it makes sense. Okay, so we have a fundamental assumption that AI keeps the data more warm. Maybe we move ahead here and let's talk about this going forward. I think the key realization is that it isn't stateless, right? Inference, especially when you have thousands or more users and conversations happening, it's more stateful. Is that your perception?
Yeah, because when you are in a conversation and you may have uploaded an image, a PDF, all the context that you need, this creates a lot of tokens,
Mhm.
and the tokens go into a cache, right? What you call the KV cache, because you cannot keep all of that in memory all the time on the GPU. And even if a model has a lot of memory, it doesn't access all at once. And it could be that if you come back to your discussion 2 days from now, everything has to be refreshed from storage, right?
Yep.
And this is a lot of back and forth, loading, unloading, these kind of things, right? And we feel like object is trying to become more and more useful because we are abstracting the GPU location from the storage location. And object store is a good tech to completely give you a virtual distributed address space, right? But that means some of the data comes from a RAG system, and the
Mhm.
latency can be acceptable to be in the milliseconds. Or the data could come from the KV cache, and then you need microseconds.
Yeah. Yeah.
But all of these, you want to use one large pool of storage. You don't want to use multiple silos because that's hard to manage.
Yeah, and that's really been, I mean, for 15 years or longer in your case, we've been involved with this. The advantage of object storage is scale, right? It's very clear we can make these things very big and grow them seamlessly. But this question of latency now becomes more critical, especially as you said, with all of these tokens and state. So that's where we need to start thinking about how to make
Yeah.
the performance angle really fit.
And NVIDIA announced Dynamo.
Mm-hmm.
which I'm sorry, but it looks like when we solved the email problem in the
Mm-hmm.
past,
Mm-hmm.
where you had, think about the GPU as your email server. You used to have this email server connects to these two arrays of
Yeah.
storage, right? And if you need more capacity, well, you cannot use the capacity you deployed yesterday on a different silo because they are
Correct.
not interconnected or they cannot talk to each other. Now
Yeah.
with Dynamo, you have much more virtualization of the storage location from where the compute is.
Mm-hmm.
And now you can use any number of compute with any number of different storage systems via an abstraction layer. And I think object storage is really, really built for these kind of use cases.
It's such an interesting parallel, right? I mean, you say email and it sounds so legacy, but the idea of tens of thousands of conversations and massive concurrency and all of that, it clearly is a parallel. All right. Well, let's move forward then and talk a little bit about how object storage might evolve and, really sort of, like you said, abstract these different personalities.
Yep.
We'll have a constant namespace, a constant API. So it's kind of looks like a same object backend, but what we need is for it to sort of abstract these different
Yeah.
personalities.
So what we see coming is the S3 API as the de facto standard. And with project like QObject, you get all the direct NVMe access to your data via RDMA between GPU and storage natively from the object store. And now your DRAM, USSD, UHDD, different flavors of SSD or HDD and tape get all under the same technology.
Mm-hmm.
There's no
Right.
file system somewhere, block somewhere else, directly attached at another point, and finally tape. They all go through the same S3 API. The object have the same metadata attached to them, and it's all continuous as part of the same platform.
Yeah. It sounds hugely advantageous so they don't have to bounce around between different storage interfaces and protocols and all of that. So I guess the question on everybody's mind, of course, is can object storage go fast enough to provide this kind of ultra low latency that we need here, right? So maybe we can explore that on the next slide.
Yes.
Yeah. So I think this is, you touched on it, right? GPU direct and Q object, which is coming from NVIDIA. Can we get this to the levels of latency that is demanded here? And maybe we can talk about it in the context of our own offerings.
Yeah, so the way we look at this is all of this is going through the S3 API, except for what we call the AI API. I can talk about that more afterwards. With a Q object or QObj, you can access any data in a Scality object storage system via RDMA, so directly from the GPU to the data. So that gives you the smallest latency you can get because it's directly hardware to hardware, right? And so that's where you go via 50 microsecond. This would work on Flash, of course, natively. We're also working on a bridge because we're implementing our own user space, if you want, RDMA, so that we can also get data from drives via RDMA. So two different type of storage, same API, same protocols. This matters a lot these days in light of a shortage of Flash and how
It does,
expensive
yeah.
Flash is. You don't want to change your application because Flash is expensive. You want to keep everything the same. So we abstract the disk so that it behaves. It looks the same way from an application point of view.
Yeah, that is such a huge point. I think everybody knows that the industry is suffering a NAND flash shortage and, supply is tight, prices are high. So I hadn't thought about it, but it's yet another advantage, right? Keep a constant interface, but yet you can vary the qualities or the amount of storage that is behind
Absolutely.
it all, right?
And
Very,
you
very
see that
relevant.
as the capacity grows, sorry, yeah, you see that the need for latency becomes more and more relaxed, right?
Right.
Until the tape, and then we're going to use the right media. But from your application point of view, you don't need to know.
It really, like you said, it gives us that single namespace through the de facto API, but we get these different personas behind it as we need. Makes a lot of sense. Okay. Um, let's go forward here and dig a little bit more into it. So getting to this, 50 microsecond type latency, it's achievable, right? I mean, you talked about going hardware to hardware. Is this near term? Is this something we can get to in 2026?
So I will need to check if QObj has been officially released yet.
Hmm.
But it's yeah, for sure it's a 2026 date. I'm sure the GTC in San Jose is going to be big on QObj.
That's right.
We plan to be there, absolutely. And you're going to see more and more demand for use, I guess, for object as a first year.
Yeah. Yeah, and we should explain to our listeners that Ring XP is a product we've had in the market for well over a year. It's really our extreme performance flash edition. So what you see in the orange boxes is there today. And as Giorgio said, we're working with NVIDIA to make sure that the GPU Direct is ready as soon as it's
Yeah.
live, as soon as it's been released. Okay, so this really, again, it gives us this ability to go from ultra low latency to these huge capacities and, again, span the different personas that we need.
Yep.
Okay.
And there's debate between TLC and QLC for this layer. So we can use both. But NVIDIA, I see in a lot of documentation, they ask for supporting 3 full disk writes per day. That skews the choice for TLC more than
Got it.
QLC.
So more write intensive, write
Yeah.
durable type media. That makes a lot of sense. Okay, very good. All right. So I guess in summary, what we want is people to really think more about simplicity, right? Single namespace, but you have intent. Workloads have intent. And it gets you out of this puzzle of thinking, what media do I need where, right? That's
Yeah.
sort of the change in behavior that we're thinking about.
Yeah, and as we see that the cost of storage, especially flash, is increasing, you don't want to use a technology that you don't need for something that can tolerate higher latency or is not accessed as often.
Yeah, that is a good point, Giorgio, because we've seen a lot of offerings say use Flash for everything, use QLC for everything, and I think maybe that is not the right model, huh? So it's really more of figuring out the right thing, and this helps make that simpler.
Yeah, as long as you offer the same API and the same protocols, this way your development doesn't change. And you can, if you decide that it's a different class at the end of the day, you just change the endpoint or change the zone. In the S3 speak, you decide to store in a different
Yeah.
availability zone, and you're going to get the same behavior at a different performance point.
Yeah. It's quite the evolution if we all think about it now from 2010 when we didn't think S3 would be our de facto API or it wasn't sure yet to now it is, and now it's being readied really for use within this new world of AI. So it's
Yeah.
great to see the evolution.
Yeah, just one thing to add to this, Obj doesn't need AI, right? Because it could
Hmm.
be used by anything that's on the RDMA network. So we're
Yeah.
actually thinking about using this for backup and fast restore for backup as well.
Yeah.
So you would see some innovation in AI is going to benefit storage for other use case entirely.
Okay, good point. You're right. Anything that requires low latency access can benefit. And you're right, in this world of cyber threats, doing restores as fast as we can is another critical use case for that. So it makes total sense. But we get AI as sort of a forcing function to help us get there. So that's great.
Mhm.
Okay, so I think we are thinking about this differently, a new mental model. And just as the slide says here, right, we want to keep it simple, but have these different classes under a single platform and let the software provide the intelligence to decide what's optimal. It can help you decide that. Any closing comments from your side?
Yeah, Paul, I don't know how much you can say about SDP, just
Oh,
as a
yes.
teaser.
Yeah, as a teaser, we are obviously readying the new generation of our own technology. We've talked a little bit about Ring for many, many years and Ring XP for the last year plus, as I've said. SDP, as Giorgio is hinting at, is more in the arena of data platforms. Data platforms provide sort of these baseline services and then additional rich services at the top, more optimized for these kind of workloads. We are absolutely on deck to make an announcement in the coming months. So SDP, keep that acronym in mind. And again, the last two words are data platform. So I think you can figure out the rest. But that's a very good thing to mention as a teaser. Okay, with that, why don't we wrap up? Thanks for your time, Giorgio, and all the input.
Thanks, everybody. Thanks, Paul.
Bye bye.